This is the third video of the series about pfSense and UniFi Layer 3 switches. In previous video, we discussed the simple scenario where you only have one UniFi Layer 3 switch in your pfSense setup. In this video, we will look into two switch setup to see what configurations are required to make them work as Layer 3 switches. This is my lab environment. I run pfSense on a mini PC. The one part is connected to my home network for internet. The first UniFi switch is a 24-port USW Pro switch. It's layer 3. The second one is a 24 ports PoE switch. I don't really need PoE in this video, but this switch happens to be available at this moment, so I'm using it. It's part of the enterprise product line, so of course it supports layer 3 routing. Based on what we already configured in previous one switch scenario, we will create two VLANs managed by the second UniFi switch. We will SSH to the two switches to check the backend setting. Then we will proceed with settings in pfSense. We will examine whether the routing works between the two VLANs in the two different UniFi switches. We will discuss what we mean by first UniFi switch. Because many heavy liftings were already done in previous video, this video should be relatively easier. Let's see. Let's get started. This is the screen layout I'm going to use for this video. In the lower part of the screen, you can see three different Linux desktops. One for a VLAN in the first UniFi switch, the second one for a VLAN in the second UniFi switch, and the third Linux is to SSH into the two UniFi switches. At this moment, in both pfSense and UniFi Network Controller, we have the network configurations we made in previous video, which means layer 3 routing works for the first UniFi switch, but not the second one yet. So in UniFi Network Controller, go to Settings, Networks. You can see VLAN 111 and 121. They are already there, together with the special VLAN 4040 for inter-VLAN routing. We just need to create two more for VLAN 131 and VLAN 141. Click Create New Network. Start with VLAN 131. In the router dropdown, make sure we select the Enterprise PoE switch. Deselect the Auto Scale Network. Change subnet to 131. Then click the Menu button. Again, the same bug, but no worry. Simply reselect the Enterprise PoE switch. Then everything's back. For VLAN ID, let me change it to 131. We are done. Click Add Network. And fast forward, let me create VLAN 141. Okay, now we have the two new VLANs created. They are both managed by the second layer 3 switch. Now we can assign the new port profiles so that the two Linux clients, they can receive new IP addresses. Go to Devices, choose the Enterprise switch. Click on Ports, then Port Manager. For the first port, let me change the port profile to the one we just created, VLAN 131. Apply changes. In the similar way, for the second part, choose VLAN 141 port profile. Now we can go to the two Linux to refresh IP addresses. First, start with Linux number 3. Okay, refreshed. Then Linux number 4. Okay, refreshed. Then let me validate their IP address is really changed. So for Linux 3, the IP address is in subnet 131. For Linux 4, yeah, in subnet 141. Now we are ready to validate whether the communications are able to be established. From Linux number 3, let me ping the Linux number 4. Okay, no problem. Then run traceroute. Okay, so the routing results are very simple. So the inter-VLAN routing between 131 and 141, it already works for the second switch. Now let's check the communications between the two different switches, more specifically between VLAN 111 and 141. Okay, here I'm showing you the Linux number 1, which is supposed to be under VLAN 111. Let me check the IP address. Yes, it's in subnet 111. Then let me ping the Linux number 4. Yeah, it's successful. This means without any additional configurations in pfSense and in UniFi network controller, the inter-VLAN routing between the two UniFi switches, it already works. Cue the ping. Then let's try to understand how the routing works. Let me run traceroute. So the result is surprisingly simple. Let's check to see whether we can understand it. First, it reaches 111.1, which is the gateway for VLAN 111. No problem for the first hop. And then the second line is strange. If you watch my previous video, you must be familiar with a similar IP address which ends with .2. It's for the VLAN 4040 address for the very first UniFi switch, right? This .3 IP address we see here seems to be related to the second switch. But the problem is we did not make any changes to the first UniFi switch. How did it know the existence of the second switch and how it knows how to route the traffic to it? To answer the question, let's SSH to both switches. From the UniFi network controller, we can tell the IP addresses for the two switches. Then in the Linux machine, let me SSH into them in these two separate terminals. Okay, in the left side terminal, let me SSH to the first switch. Then the right side terminal to the second switch. Make sure you read the notices and take your own risks if you decide to proceed. In the first SSH, telnet to itself, en for enable. Let me run this command, show IP interface brief. So for VLAN 4040, the IP address is the .2 address, which we already talked about in my previous video. No surprise. In the right side SSH, let me do the same thing. Run the same command. Okay, now we can confirm the .3 IP address, which we saw previously in the Linux client in the routing, is the interface IP address for VLAN 4040 in the second UniFi switch. Then let me go back to the left side SSH. Let me check the routing table. Run command show IP route. It's much busier than the routing table in our previous video for one switch scenario. But hold on, let me show the routing table in the second switch as well. Go to the right side, run the same command. Okay, so the result looks similar to the first switch, right? Let's examine them one by one. In the first switch, so you can see there are two types of routes. C for connected, S for static. So the first static route, by default, route via the default gateway, the .1 IP address. Nothing's new, the same as in previous video, right? Let's check the other two new routes, which we didn't see in previous video. They are static routes, and they are only here because now we have two layer 3 switches. For the 131 subnet static route, it says, okay, for this subnet, let's route via this IP address. The next one, for subnet 141, let's route via the same IP address. What they say exactly? They simply say, for these two subnet, 131 and 141, let's route to the second switch. Why second switch? Because the IP address is .3 in the right side. We already checked. .3 is the second switch interface IP address for VLAN 4040. So these two static routes in the UniFi switch explain the trace route result we saw previously in the Linux machine. I already draw the diagram. Let's check how it works in a more straightforward way. So for VLAN 111, we ping the machine in VLAN 141, right? The traffic first reach the router in the first UniFi switch, then route to the second switch via the static route, the pinkish, purplish link I draw here. And because the destination is in subnet 141, and in the switch routing table, you can tell it should use this static route. In the end, the traffic reaches the other Linux machine in VLAN 141. Okay, so now we know the second UniFi switch has the .3 IP address for inter-VLAN routing. Let's address a question that some of you may have. What we mean exactly by first layer 3 switch? So we mentioned the word first many times already. Let's check the network diagram. First switch doesn't mean the switch is the closest one to the pfSense. No, even if let's say you connect the PoE switch to pfSense, then link the USW Pro 24 to the PoE switch, so you will get the same result. Pro switch will still be the first switch. And the first switch also doesn't mean this switch has the smallest IP address or MAC address. No, it's nothing about that. And the first switch also doesn't mean this switch is first adopted or rebooted. No, even if let's say you adopt the enterprise PoE switch first and then the Pro switch, if you follow the same configuration steps as we did, you will get the same result, which is the left side switch will be the so-called first switch. In fact, the so-called first switch is just the switch that acts as the very first router in your inter-VLAN configuration in UniFi controller. In my case, because in previous video, I started with the Pro 24 switch by defining VLAN 111 and 121, right? So then the Pro 24 switch has been treated as the first layer 3 switch. Hence, it received the .2 IP address. So in this video, we use the enterprise PoE switch as the second router in our inter-VLAN setup. So that's why it received the .3 IP address. So it's very simple. Having this cleared, let's proceed with the pfSense configurations. As we discussed in previous video, without pfSense side setup, the two VLANs 131 and 141, they cannot communicate with the outside world. For example, here from the Linux number 4 machine, if I ping an IP address in my home network, which is in the WAN part of the pfSense, let me ping this IP address, the .2 IP address, which is outside of our lab environment. Let me ping it. No, it doesn't work. So in pfSense, as the result of our previous video, we already had the VLAN 4040 defined, and the interface for VLAN 4040 is also ready. Check the interface setup. The IP address, the .1 IP address, is not changed after we introduce the second UniFi layer 3 switch. So we can confirm from both the SSH sessions, right? In the first one, .1, in the second one, .1, right? So the introduction of second UniFi layer 3 switch doesn't impact the pfSense side VLAN 4040 interface IP address. In previous video, we also have the firewall rules defined for VLAN 4040. We simply allowed any-to-any. So what we are missing? We are missing the static routes in pfSense. As you may know, we need to first have a gateway if we want to introduce static routes. So let's check the gateway we already created in pfSense in previous video. Go to routing, check existing gateways. So you can see we defined the so-called first UniFi layer 3 switch gateway in previous video. Go to the setup details. The most important information is the gateway IP address and the interface. Of course, for interface should be VLAN 4040, but the gateway IP address part, what the .2 IP address is, it is for the inter-VLAN routing interface for the first UniFi switch. In the lower part of the screen, you can see the same information here, right? But if you check the right side for the second UniFi switch, here comes the question. Can we simply use the existing gateway we already had for the static routes to the second UniFi switch? We can try it. Let's test it out. This is what I'm going to do. I will use the existing gateway in pfSense to create new static route for VLAN 131. And then I will change approach. I will create a new gateway for the second switch. And then I will create a static route for VLAN 141. Basically, I will create the two static routes in two different ways. Then we can compare the result. So first, for VLAN 131, let me create a static route using the existing gateway. Click Add. The destination network for VLAN 131 is in the 131 subnet. Subnet mask is 24. For gateway, remember for VLAN 131, the approach I'm going to take, let me choose the existing gateway for the first layer 3 switch. Save it. Then let me take another approach. Let me first create a new gateway. The new gateway is for the second UniFi switch. For interface, of course, it should be VLAN 4040. Let me give it a name, second UniFi layer 3 switch. And here comes the most important information, the gateway IP address. Let me give it the .3 IP address, which we got from the SSH session, right? Okay, this is the IP address. Then save. We have the new gateway created. Then we can proceed to create a new static route. For subnet, it's for VLAN 141. Subnet mask is 24. The gateway, let me choose the one we just created for the second UniFi switch. Save it. We have everything created in pfSense. Let me apply changes. To show the different behaviors between the two static routes we just created in pfSense, I need another machine within the pfSense network. Let me use this particular Linux machine. It's in the LAN part of pfSense, not in the VLANs managed by UniFi switches. Let me get IP address. 1.231. So in this VLAN 131 machine, Linux number 3, let me trace route for this IP address we just got in the right side. Trace route against 1.231. In the Linux number 4, which is under VLAN 144, let me do the same thing. Trace route the same IP address. See if you compare them side by side, they have the same results. Of course, the first hop, they will jump to the corresponding router in the given UniFi switch. Because in pfSense, we selected different gateways for the static routes. There's no surprise about the first hop, but the second hop and the third hop, they are exactly the same. Which means for these two Linux machines, when they reach the destination LAN machine, the routing works in the same way. But what about the return path? So when the traffic returns from this right side Linux back to them, whether the route is still the same. To validate that, let me do the trace route from this right side Linux machine, which is in the LAN part. Trace route the VLAN 141 machine. The same thing, but for 131. Interesting. Back to VLAN 131, the second trace route, you can see an extra hop. But why is that? See the pfSense static routes definition for VLAN 131. The gateway is the first UniFi switch. So it makes sense if you check the traceroute result. The second hop is to the .2 IP address. So see what happened next. The third hop is to the .3 IP address. If you check our previous SSH session result for the first UniFi switch in the routing table, there's a static route to the .3 IP address for static route. So that's where the third hop came from. So once the traffic reached the second switch, the last hop, this particular one, makes sense. I hope now you understand the difference between the two different ways to define static routes for the second layer 3 UniFi switch. Yes, both works as we already validated, but the first way to reuse the first UniFi switch as the gateway will lead to an extra hop during routing. So you may want to avoid that. You may want to introduce a new gateway like what I did for the second static route for the second UniFi switch, and then define the static route using this new gateway. Let's look at this illustrated routing path. In that way, your routing will skip the first UniFi layer 3 switch, and it will only be routed via the second layer 3 switch. Of course, that's more optimal than routing through both UniFi switches. Now we are at the last step for this video, Internet. If you watched my previous video, you may guess it right. At this moment, Internet does not completely work for VLAN 131 and 141 yet. For example, in the Linux number 3 machine, let me try to ping an Internet IP address. Yeah. The ping is successful, no errors. However, if I ping a domain name, let me do it in the Linux number 4 machine, it doesn't work. If you want to see the reason, let me dig the domain name. As you can see, DNS server is the .1 IP address, which is the default gateway for the two UniFi switches. The value is correct. But see the warning message here? Recursion requested but not available. And you can find the exact reason if you read this part. The Linux machine did reach out to the DNS server, but the request was refused because we need to manually allow it in pfSense. So let me do it. You can go to Services, DNS Resolver, then click Access Lists. As part of the previous video, I already added two access lists for VLAN 111 and 121, right? So this time, let me add another one for both VLAN 131 and 141. The action is allow, and the network is the two subnets. First, add the subnet 131. Subnet mask is 24. Then click Add Network and the subnet 141. Okay, save. So in this way, we added a access list for both subnets. Apply changes. Now if we go back to the Linux number 4, try the previously failed ping. See, it does work now. If you want to see why this time it works, let's dig the domain name. You can see it still reach out the same gateway, but this time the gateway works. It did receive the answer because we just added this subnet to the pfSense DNS resolver's access list. If you want, you can try internet browsing. We successfully visited the website for this domain. Okay, this is the end of the video. Thanks for watching.